Hi. According to much research, the cost of acquiring new consumers is one-fifth the cost of keeping existing ones. And for these reasons, banks have started to adapt customer analytics. However, sometimes things may possibly go wrong, resulting in poor and inconvenience for customer experience, who may eventually decide to end their relationship with a bank, which may lead to a significant reduction in revenue. In this vein, Alexandre and Ital have provided good work in examining the factors that led to customer churn in banks and build machine learning models for further customer attrition prediction.
Let's move to the methodology of this paper, where we seek to present the main variables used, continuing with some statistics, followed by the methodology employed. This dataset is obtained from Kaggle to predict what's known as attrition in the banking field. It consists of 10,000 records and 12 variables as follows. The customer ID would be treated as the unique client identifier, then 10 independent variables, namely credit score, geography, age, tenure, balance, number of products that he or she holds, binary variable for whether he or she has credit card or not, binary variable for whether he or she is an active member or not, and his estimated salary, all of which will be deployed to predict the target binary variable exited, which takes 1 if the customer churned and 0 if the customer is retained. As the data preparation step, gender is hot encoded into a binary variable of value 1 for male and 0 for female. The distribution of customers reveals that the churn rate is 16.15% for France, 16.67% for Spain, and 32.44% for Germany. Since France has the lowest churn rate, the study will mainly focus on customers from France. The classification tree methodology involves using two machine learning models, namely random forest and logistic regression. Two regularization techniques are also used to make them less complex, namely lasso and ridge regressions.
This part discusses a comparative analysis of the churn rate by three main variables, which are gender, age, and number of products customer hold. To start with, this chart depicts the churn rate by gender in each of France, Germany, and Spain. We can see that for the three countries, women drop out banking services to a greater extent than men. For example, in France, churn rate of women is approximately 20%, however, it's just 13% for men. Also, Germany is noted to have double churn rates for both genders than France and Spain. These figures show the age distribution in the three countries according to whether customers churned or not. We can notice that in all of the three countries, customers with higher age tend to churn more than those with lower age. This means that age is a strong discriminator when deciding whether the customer is at risk to churn or not. The cluster bar chart portrays the distribution of the number of products customers hold according to whether they have a churn or not. The blue bars at each number of products represent the percentage of churned customers at this specific product number. We can observe that customers with large number of products tend to churn more than those who have fewer products. For example, we can see that 100% of customers with 4 products have churned. This might happen because of large fees and commissions for additional banking products or services, which forces customers to look for better offers from other competitors.
The study used an ensemble method called the random forest model. It's a supervised machine learning algorithm that's based on building several decision trees, and then the predictions for these trees are combined together through the majority vote to obtain the final prediction. The researcher used an optimization method called grid search to find the optimal predictive model. Grid search uses a cross-validation technique by which the machine learning algorithm can be evaluated on test subsets in order to find the best model that has the highest accuracy and stability at the same time. This provides multiple combinations of models to be fitted based on an input of parameters chosen by the analyst, and provides an output with the best recommended model using a performance metric which is chosen before building the model. In this study, the combinations of parameters were tested using grid search with 4 alternatives for the number of estimators and 6 choices for the maximum depth. The evaluation metric used to evaluate the model results is the AUC score. The optimal model is found at the number of estimators equal to 500 and the maximum depth equal to 7 levels, which is highlighted in the graph in the blue dashed line. The best random forest model for French clients got an AUC score of 0.85, while the baseline model for the same classifier with the default parameters got an AUC of 0.82.
The second model that used in this paper is logistic regression. The paper defined logistic regression as a statistical tool that used to model the relation between a dependent binary variable and several independent variables. The specific object of the logistic regression model is to predict and understand the factors that influence customers to churn or close their relationship with the bank. In this model, the author uses two parameters through the graded search technique that are L1, which is called lasso, and L2, which is called range regularization. The next slide shows two heat maps. We can observe that the best classification results are obtained using L1 technique because the L2 technique underperforms. In addition, starting with a penalty coefficient of 0.1. The optimal model for France has an AUC value of 0.73. A significant improvement over the standard non-optimized logistic regression model has an AUC of 0.63. These optimal parameters are L1 lasso regularization with a penalty coefficient equal 1.5849.
So, based on what have been discussed, this paper concludes with three main points. Firstly, the main factors that impact on customer attrition were age and the number of products held by clients. And as for machine learning models, Random Forest offered the best model with almost 0.85 compared to just 0.73 for logistic regression. However, this paper recommends further studies to apply more machine learning models. And that's all for Alexandra work and how to tackle customer attrition impacts. Thanks a lot.